Hello, everyone. This is another episode of Hydra Book Reading Club, and in this video, I'm going to explore further into modulation, and it will diverge quite a lot from the Hydra book. And this is in the background is something I will try to make today. I was just testing it before filming, but I'm going to just clear it and start it from scratch. But the departure point, so in the last video, I didn't code Hydra. I was explaining it. I was explaining how modulation works in P5.js. Well, using P5.js as to illustrate how it works. And in this video, I'll jump back to Hydra editor and try to make something. But the point is, okay, I will just make myself small, and I've been having hay fever, and so not really comfortable to make myself big on the screen. It's okay. So this was what I explored in the last video. Like, this is pseudocode, and I implemented this in P5.js because it's not easy to do this kind of coding in Hydra, and explained how it works. And either you watched it, either you understood or not, I'll try to do something a bit more than normal modulation. And I've been explaining this in different series of my Hydra tutorials, but I think it's good to come back to this topic of how to play more with modulation. And it may be a little bit tricky. It may be how they say, my thoughts are a little bit all over the place. It's very difficult to explain precisely how things work, but you can always just copy the code and play it and do something on your own. So don't worry so much. And yeah, so the departure point is this one, exactly this one here, feedback with modulation. That at that time I was, well, I still think this is kind of interesting example. And let's say this one. So yeah, okay, I was using modulate with O0, but I can do the similar thing. I'll just clear it. Well, I just press the bin button or trash can button. And basically what I was doing is, say I have Voronoi, and well, I have Voronoi, maybe I'll make it static like this, and I can use O0 and modulate it by Voronoi. So as if you watch the intermediate tutorial, I will if I use feedback, I will make sure that the factor for pushing the pixels with modulate, I will make it small and see what's going to happen. So this is something that will happen. It's a little bit different from the example because I think I flipped it. In that case, I did something like this. O0. Oh, it's kind of funny. Does it really look like this? Yeah, because I think I was blending it here, right? So I had to this is blend it with O0. Yeah, I mean, it's not so obvious. Maybe the modulate can be a little bit further. Yeah, the image still looks a bit noisy, but it's kind of interesting to me. It's, as I explained in Hydra book, it's like a fake 3D, right? So if I go back to, or maybe I can't go back because I didn't, well, maybe press back button and then maybe it will go back here. This is quite interesting. That is, if you observe this, what is happening visually as an effect is that the pixels are kind of it's like a river that's going, I'll just run it again. It will just go towards, okay, it doesn't work that way, so I have to do Voronoi again, out, and run this again. So it's going towards top left, and this is, it's nice. If you want, you can also do something to see the sandwich. So now if you watch the intermediate tutorial, I explained it as a sandwich. So I have the source and out, and here I want to inject something like a ketchup that's injecting, or mayonnaise or whatever, into the sandwich, which is in this case layer, and I'll just take the same pattern, Voronoi and Luma, something like this. I think this would work. So only the brighter pixels remain there, and it is like feeding all the time. So now it doesn't go all the way to the top left, but the bright pixels remain there, and you can see that the river, the trace of the river, let's say. And you can also make a little bit of movement. I'll just make them move together. So now it has the movement, but as you can see, constantly the flow is towards the top left. Why is it top left? Because if you watched the last video, I explained like modulate is affected by red and green channel, and I think I didn't really do like a good job explaining what is this red and green pixels, because it's really hard to explain. So that's why I'm doing this another try to explain and elaborate a little bit more on that. But basically, we're just like sampling from minus x minus y or whatever pixel, and it's always like we're going to top left. Or another reason why is that now we're only working with grayscale color. So red and green channel, they're always the same, because if it's grayscale, that's why like red, green, blue, they're always the same. That, I mean, in the grayscale image. And that's why like we're having this constant like same direction of the flow. Either it's slow or fast, it's always the same direction, because red and green always the same, or and blue as well. So now what I want here is, instead of like having this grayscale image as a modulator, which is this one, as you know, Voronoi, I mean, if we go back to this is grayscale, and I don't want grayscale. I want like a colorful Voronoi, so that the colorful Voronoi can move pixels all around the place, like all around, like the direction wise, like it can be circular or it can be radial or whatever, but I don't want something that is like always grayscale and pushing to top left. I mean, this is one effect that is like interesting as it is, but if I want to have variation, I don't want to stick to this grayscale Voronoi, and I want to work with color Voronoi. And one like downside, or how to say that, the way Hydra is designed is that it's not really easy to color this. Like, of course you can do like color, and you've seen this trick, like 1 and -1, for example. So you have red and blue, well, red and green channels, and this may be one way to trigger that. So now it's not just moving it to the top left, but I actually did it like in a really clean way. In this example, I just came up with this, but now it seems like not only top left, I mean, it's kind of the same direction, but also like towards the top, towards the left. It's a little bit of variation is happening, but it's still not going towards right or towards downwards. This is because the color we're seeing is always like from 0 to 1. Like I talk about this, right? 0 to 1, or in P5JS it's 0 to 255. But if you want to reverse the direction, you have to have negative numbers. And to do this, you can always change brightness -0.5. And this is something, things get really weird, because if you just look at this, I haven't evaluated this. If you just evaluate something like this, then it's like dark color and it's not really interesting, but the black part, this contains variation of negative colors. So we're only seeing its black color, and it's only rendered as black color, but it has some variation, like -1 versus 0. It's just rendered as the same black, but it's like more black versus less black. That is like what is contained before rendering. And what is contained is what is actually important for modulating. And if you do this, you can start to see that it's not only, well, actually now it's like reversed. It's going to like right direction. And it may be because of this color. I'm not really sure, because maybe one -1 is already containing negative color and I'm amplifying it. I don't know what is really happening. But maybe you can like tweak it a little bit and have a little bit of like, try to have different variation so that now it's slowly start to see that some pixels are going towards the left, but also like in time it goes a little bit towards the right. It's still not going downwards though, which may be related to this direction. Oh my gosh, it's going a little bit out of control. But yeah, so you can like try to like tweak this parameter in here, but still like I found that this is like not the best option to work on it. And if I want, like in the beginning I showed like going all over the place, the pixels moving all over the place, I found very effective way to do it, which takes a little bit of time to like code because, and it's a little bit cryptic. You might want to just copy and paste and use it for your project or code, or if you follow along, maybe you will understand a little bit of like what's happening inside. So because I started with Voronoi, in the video I used, in the original one I used noise function, but I can also use Voronoi for this. So let's just take this color out again. I just have this Voronoi and I want to color it, but also like not just like red and green, but I want like different colors, like also like yellow should be there as well. And that's maybe why the initial attempt that I didn't work, because it feels like there's no like, because I want some yellow that is containing both red and green, because we're not only interested in pushing the colors to the left or towards the top, but it can be top left again or right bottom or whatever. So let's see how it can do this. And if you think about like different colors in Hydra as a source, what comes to my mind first is OSC. I mean, not this OSC, but okay, let's just slow it down or stop it. If you have the last third argument like this, or parameter or whatever, then you have nice colors. And my first thought was like, how can I use this to color this one? So it's not just like grayscale, but some of these Voronoi cells have like blue, but also some have having yellow, red, green. That would be quite nice to have. And then we can move pixels all over the place. And to do this, basically what I'm going to do here is I want basically to have some kind of a palette of color, and Voronoi is going to use this palette somehow. And I just picked 6 because, well, precisely it's pi times 2, because that will give like one screen, like a full width of the screen with like one cycle of OSC or sine wave. So now you can see that you can, the colors are like different across the screen. And if you increase a little bit, like 12, then you can see that 2 cycles are there. I mean, almost, it's not really precise because it's not, it has to be pi times 2 times 2, which is approximately 12. So that's what I'm doing here. But I would do 6 just to make it simple, because it's not like I'm not going there like really precise here. And by the way, this 1.6, I did use it. I used it like without explaining too much, but this is exactly, well, it's not exactly, roughly pi divided by 2. But you don't see much of a difference here. Well, or 3.14 divided by 2, which is roughly 1.5 or 1.6. So I use this number. And what I'm going to do here is I want to use this as a palette to color Voronoi. And if you think about this, the easiest way to kind of use this color palette or color scheme to color Voronoi is you can just do modulate, just like the whole topic today, but not just like, you know, this simple modulate, you start to see this kind of like a trace of Voronoi, but this is not enough. And you usually probably like don't want to like use big number for modulating, but you can go wild actually. There's nothing stopping. I mean, if you're doing feedback, you might want to stick to a small number, but you can also like experiment like this and see what you got. Like this is like exactly what I wanted, and it's actually as simple as this. Now you have different colors of Voronoi, and if you use this, you can push pixels in different directions. So let's try it. Although this is not the final form, but let's go back to this, and what I want is, and just forget about brightness for now. So basically what I'm having here is I have the feedback from source 0 and modulating it with this colorful Voronoi that finally we made, or magically we made. But still, like, we're feeding the bright color of Voronoi as a ketchup. And let's see. So you see that it's having some kind of like curve shape, and I think now it's not moving. I'll move this again. So now, as you can see, the Voronoi, as Voronoi changes, I can also demonstrate here. I just match it so that Voronoi is moving, but the colors are kind of like staying the same because OSC itself is not moving. So this red box is like remaining red for some time. It changes over time, slowly. But as you can see that now it's not only going towards top left, but it has some variation, but still kind of biased towards top left because as I explained earlier, it's colors are from 0 to 1. So now I want to correct it by adding brightness minus 0.5. Oops, I think I added too much. Yeah. So now magically it's starting to have like more like a flow of like pixels moving. And actually, like, what I can also do here is, instead of Voronoi as layer, I can, for example, use shape for Luma as a starter. So the box is in the center and it's feedback modulated with the colorful Voronoi. Although in this case, like, you might be confused, like, where are the colors? The colors are used for pushing the pixels all around the place, but it's not present in here. If I want to color it, you can always, like, for example, multiply, or just to keep it simple, I have OSC here. This is something completely like different from what I was doing before. Like for the preparation, it's a different thing. Oops, I have this colored OSC with the mask shape. So something stays in the middle, just like this ketchup is injected as this colorful box now. And this colorful box boundaries are like pushed according to the number from this colorful Voronoi. So there are like two different colorful things happening, which are like completely different, independent from each other. So this color of the box doesn't have anything to do with how the pixels are moved, and the pixels, how pixels are moved with this Voronoi doesn't have anything to do with what's in the foreground. I can actually, like, I just thought about this, but go back to the webcam example. So for example, if I use my webcam and use that as a source, maybe that's less confusing. So now I have me in the middle, and that is like pushed away in different directions, not only to the top left, because thanks to the colorful Voronoi that we discovered, like in here, this is moving. So the red boxes, they're moving the pixels towards left, I guess, and more like green ones are just moving pixels towards top, and less green ones are going towards bottom, less red ones are going towards right, and this kind of like combination is happening so that you can see, well, it's not just like a binary, like moving this way, that way, but it has like variation. So now you can see that the flow is going all over the place. If you want to make it like not diagonal, but only pixels moving this way, you can also do that by pixelating the palette. So for example, if you pixelate it by 4, oops, not this one, sorry. But if you do it, and maybe you want to affect the Voronoi so that it doesn't really look nice. I'll just keep it like this. It's not this one, but I needed to put it in here, I think. And if I evaluate this, now it's not exactly like north, west, south, east kind of movement, but the pixels are like only moving towards like in a more like a diagonal fashion, which is also quite interesting. And it's really interesting. I know it's like really confusing, like why adding pixelate is not pixelating the image, but pixelating the direction or the vector of the pixels moving. It's really confusing, and I don't think I explained it too well. I didn't explain it well. But what's super interesting here is that you're now like adding this pixelate to change the flow of the pixels, not pixelating the image itself. Or you can do something funny like pixelate 5 or something. But it's you can still see that this movement of the pixels are still quite quantified or discrete, let's say. And I take this out again. The movements are like organic again. So you can experiment a lot. And I want to close it now, but just I have to add one more thing, because if you're curious, let's go back to this example. I didn't do it precise in this one because I went like wild, I said going wild with modulate 1, and visually I think it's okay. But if you want to be like very precise, okay, if you're very precise, you have to do math pi times 2 here, and this one is math dot pi divided by 2. It changes a little bit actually, the shade, so maybe it's also good to know. If you want to like be very specific or precise, this is the way to go. And if you are really picky, like I am, here I would add sub gradient, and this is like a really like a weird magic trick that has to be like added if you want to be very precise about what we're doing. And I'm pretty sure this is not yet done. In the case of noise, if you're doing like noise here, I think it's okay. But if you're doing Voronoi, or maybe this is okay actually, because in the case of noise, it goes from -1 to 1. In the case of Voronoi, it goes from 0 to 1, which is very strange. Well, it's not really strange. It's just like how these functions are implemented in Hydra. And I think I've explained this a few times. But with this, okay, let's take this as a modulating function here. So instead of this, and it's still like we need brightness minus 0.5 to kind of equalize it. And visually, I think there's no difference with or without the subgradient, but I always add it just for the preciseness. And what it's actually doing is it's kind of canceling out the whole like what modulate does. Because in this last example of P5.js, or I can go back to the pseudocode, but basically what we're doing here is this green and red, they are, the red and green channels, they're moving X and Y channels, but also the original X and Y are present here. And in my case, like exactly this specific case of using OSC, colorful OSC as a palette for coloring Voronoi, I want actually to cancel out this X and Y, the original position of X and Y. And I just purely want the intensity of Voronoi, intensity of noise to color the pixel, like not the position. It doesn't really matter where of so the criteria for coloring this Voronoi is not about if it's in the middle or if it's in the left or right. It doesn't really matter. I just want to pick this intensity of this pixel, the color of the pixel. If it's black, it will correspond to, I don't know, red, for example. If it's white, it corresponds to blue. And if it's gray, it corresponds to green, something like this. It's not very precise. But without this subgradient, we're still taking into account where in the texture we're like looking at. Like if you're sampling the pixel at the top right, that already affects the color choice, which we don't want. But visually, again, like this versus this, I mean, you see a difference, but like, is it something like really critical? I don't think so, unless you're doing something really precise that you want to move pixels in a specific way. And I sometimes do this kind of weird stuff. But if you just want to like move pixels around, then this subgradient is not really necessary. So if you have this versus this, it's visually, I don't think there's difference. Although this brightness is super important, because if you don't have this, then pixels are always like flowing towards the like kind of same direction, and it's not going backwards. So I want this one anyways. And to make something like similar to the start of the video, I used a sketch with noise, and if you just do noise, then you can have something like this. In the case of noise, it's a little bit too fine grain, so maybe I'll relax the first parameter of noise, something like this, and you can see that my colors are bleeding in like different directions. And again, just to emphasize like why I'm doing this, because if I just take this noise function as a modulator, then it will just flow to the same direction, well, this or that. I don't know, maybe I'm doing it all the time it's wrong. Anyways, so I hope this is something, and I will just maybe clean up the code here, and well, I can do Voronoi version like this, and I'll put this code in the description down below. So if you're lost, you can always just copy this and use this. Like, feel free to do it, and you don't have to attribute me. It's like almost like public domain. So, I mean, if you're teaching with this material, it will be nice if you can like refer to this series or Hydra book and so on. But for your creation, you know, it will be nice if you can tell me in the comment down below, or if you can write to me. I have my email address and contacts on the YouTube profile, so please let me know, and I would love to see what you create. And please share down below or in the community on Facebook, Discord, whatever. And it will be nice to see you in the next video. So please hit the like button if you find it useful. And if you have wishes for the next tutorials, please let me know so I can do something that is actually wanted from the community. Okay, then have a happy coding. Bye.